I teach. I'm going to focus on my third year modules, but I do sort of similar as well at honors as well. Okay, so our BSc, so I teach on the mathematical statistics side. So this is a very one-sided take on it. So I think the structure looks quite similar to most of our BSc sort of math stats degrees. So we've got math stats and mathematical statistics and mathematics in all years. And I teach at third year level these two underlined modules here, which are both mathematical statistics modules. The WST 312 is stochastic processes, and it's a core module for our BSc students. The WST 322 is actuarial statistics, and it's an elective because it's it's very statistical focused, but we've made it an elective for our own students, but a lot of them do take it. So these two modules that I teach, I just want to give you a little bit of structure of what they look like, so I can explain how I do the coding. So it's stochastic processes. We do Markov chains and then Markov jump processes. It's 18 credits, so that requires them to spend 180 hours to master the material. It is part of an actuarial exemption. However, so in the class, you'll have the actuaries and the stats students as well. But I don't focus from an actuarial perspective. So I obviously acknowledge there's other students in the class. However, the course is very theoretical. So it follows quite strongly on from our second year in mathematical statistics. There's a lot of definitions, there's a lot of proofs. This was notes that were handed over to me 16 years ago by Professor Dion van Zyl. And but the notes they're beautiful. The maths is beautiful. It's really nice. So I keep the theory there because I think it's really important for the students to understand the base of what our statistics is, which is exactly what a number of people have said today. And I expect them to understand the proofs. I don't if they just learn them off by heart and they start making mistakes, you can see it, and they lose marks. And I'm quite strict when we mark it, because I want to see that they understand it, that they haven't just learned it off by heart and left out an explanation and that sort of thing. They're very strong students, so they manage fine, but I think they do think they're challenged a bit with me. So this is the breakdown of the semester mark. I do some online pre and post tests. Those are automatically graded. That's to keep them on track. Gone are the days where the students look after themselves, so you sort of have to help them a little bit. So they expire, they're open sort of Friday morning to Monday evening, and they have to do that before they come to the first lecture of the week. I also have each week an online practical, also similar a small online that's automatically graded, just on ClickUp, not anything fancy there. And that's also to make sure that they do the practical of that week in time, that they don't fall behind. The practicals of each week follow on from the theory. So we do the theory, and then they have to code it. And I explain to them, my focus is always the practical work there is really important, because you can't, first of all, you can't code if you don't know the theory, but you also don't know if you don't really understand the theory until you've tried to code it. So we have this very holistic cycle that we go through. We don't, like Solly suggested, do practical and theory intertwined in class, just because of the nature of the notes that we're working with, but I like that idea a lot. I also take random class attendance, because apparently you can't rely on them to come to class, and that contributes to the semester mark. And then we have actual practical tests where they have to sit and code. And what's really important that I want you to see here is how large the percentage is of the semester mark. I've made it really large. It's larger than one semester test. So the 2 semester tests each count 25%. That only makes up half their semester mark. They have to master the coding in order to get a decent semester mark. So you can get into the exam if you just do the theory, but obviously not having done the coding won't help you understand things, and there's that sort of argument. However, I make it quite nice, I think. We have 4 tests across the whole semester, and I only count 2. So you actually have a 15% going on here. However, if you do write more, which I obviously highly encourage because I want them to do the practical, the coding for that theory that we've covered, then I add it, and I help those 2 extra marks that they do, or extra tests that they do, increase their percentage. So it's only to their advantage. And then we have discussion boards every week as well. But this 30% is really important for me. It means that the students can't waive it. When I was a student and shortly after that, when I sort of started lecturing, we made this percentage in most of our modules really low. It was like 10% for the practicals. But 10% a student can absolutely ignore and still get an 80% semester mark and an 80% total mark for the exam. And obviously you're assuming when a student comes into your class in the following year that they could code. So that you can't sort of allow that situation to happen. So making this very large has been quite impactful. The other module, the WSC 322, is very similar in terms of the semester mark. You can see there. However, it's got quite a vastly different content, so more actuarial statistics directed, but very nice stats in there. And this is also part of the actuarial exemption. But this module is not so theoretical. It's more practical. So there are definitions and there are some proofs, and they must know it. And we tackle it the same way we do in the other module. This is in the second semester. The stochastic process is in the first semester. So the students know me already. They know how I function. But we focus more on problem solving. So they get questions related here, and they've got to set up a risk model or set up a room theory model and that sort of thing. And so for this sort of situation, the coding is really important because you really understand what's going on if you code it. Okay, so how do I do this? The WSC 312 class is relatively large. We have 220 students or so. This is a third year level. So I don't know if there's any other third year class in the country that is that large. That's a smallish class. Let me say that's our average third year class. There are larger ones. And so this is really large. So these practical tests, ideally, you would have liked, Michael is the exception and he's got a great plan going on there, but my class is too big. Ideally, you want an invigilated situation to check that they're actually doing the coding themselves. But this was not realistic with this course, WST 312. Let me just go back here. So what we do with these practical tests is they do it by themselves, wherever they want on their own computer, but are time restricted. So you have only 45 minutes to complete it and upload it onto a system called Gradescope, which I also mentioned. And the thing is, so it's enough work in the test that you don't have time to finish it yourself, make sure that it's working, upload it, and then help your friend. So you sort of, in some sort of way, make it a self-administered test. So there's limited cheating. You don't have time to cheat, let's put it that way. And it has worked very, very well. So I've done this in WC 312 for a few years already. And so Gradescope looks like this. So you have sort of your assignments there. For WC 322, slightly different. I have 150 students. I have until this year done it exactly the same as 312, but because it's an elective in our stats program, there are less students. So I've got about 140, 150, which is definitely the smallest third year class that we have in our department, not nationally, I'm sure. And SASA came to me and they insisted that this had to be an invigilated practical exam. And of course, my and Soli's colleague were like, but why do you want it invigilated? What do you want to achieve? And SAR, they don't really have a set plan for this, but it had to be invigilated. So because there's 140, I did manage to get enough lab space. And actually 2 weeks ago, we did an invigilated practical test. So it's these components here, and we did them invigilated. But I kept actually the same structure. So the only difference was that the students are in a lab and they have to work on the university computer. And then I gave them, I want to go back here. I gave them the material on ClickUp when they're in the test. So they can't take in their own stuff. So it's closed book in a sense, but I don't believe in closed book coding because when we work we don't close book code. We don't know code off by heart. So I gave them all the practicals that we did, not complete, not memos, and then obviously all the theoretical notes so that they had that. And we did this in the lab. So the open book test we did with the 312 last semester, and then I've tried for the first time now closed book invigilator test. It's a lot of effort because you have to have invigilators. You've got to get there half an hour before. It takes much more time. So in terms of human capacity, I don't think it's the ideal situation, but it worked. The students were fine. They figured out how to do it. They figured out how to upload to Gradescope, etc. The thing they struggled with was actually logging into their accounts, because when you're on your own computer, it remembers your passwords, and that got them, surprisingly. But everything else worked fine. So Gradescope is amazing. If you're not using Gradescope yet, that will be my take-home point, please. So there's a number of different assignments you can do, type of assignments. So when I upload semester tests, like Anae was also talking about earlier, you do this exam quiz and you scan the papers and you mark it online. It is faster than anything you will ever use, and I will never mark on paper again. It is so wonderful. But I want to focus here on the programming assignment, which is what I do for the practical test. So you select this one, and then you sort of set it up. Everything's normal there. And then you have to set up an autograder. And an autograder uses R. You can use Python, to my understanding, but Python is a little bit temperamental with Gradescope. Maybe it's been improved. But most people use R because it's really well behaved. So you have to set up a number of files. You zip these files. So that's the zip file that you see here, and you upload it, and then it compiles it. You can see that this one that I've copied here was built and it didn't moan and there were no errors. And you use a library called testthat in R. So testthat checks if two things are equal. So you take the student's answer for a question. So you've got to tell the student it has to be in this variable. Otherwise, it can't find it, obviously. And then you, in your memo, run the code and check that when you ran your code, you get the same answer as the student. And obviously, there's a lot of flexibility. You could throw in a different, so for example, here I gave them a certain Excel file. You could throw in a different one to test if their code is universal and not hard-coded and all sorts of things. It works beautifully. And of course, the best thing is that it auto-grades. So they upload it, they get a mark. I wanted to quickly show you what it looks like. And then, so if you go to Gradescope, it automatically grades it. So the students get a mark, and you can even see their average. So this is a really nice example. It gives a summary of the mark and why I feel this works. There are students who get naught, a lot of them, because if the code fails, they get naught. But that's correct. If you're working in a work environment and your code doesn't run and you can't share it with a colleague, then you haven't done your job. But a lot of people get full marks. So for me, the students who are doing the work get their marks as deserved. And you can see it correlates very nicely with their theoretical marks. And those that are not coding or are trying to cheat or whatever, they get naught because they don't know why the autograder fails, type of thing. And we do, at the beginning of the semester, I do a whole practical note where I show them how it will fail, how you will get naught. So they know all the pitfalls that can occur to them. So this is for me really important. I've seen how well the students enjoy coding, because a lot of students are scared of coding. So I think it's really important from first year that we do coding, because that is what they're going to work when they work as statisticians. But the theory is really important, and I feel very strongly about that, especially because I actually studied mathematics, so I'm grounded in theory. We're not going to grow our field only if we know coding or only if we know theory. Our students have to know the theory, maybe not the ones that are majoring, but the students that are majoring in statistics, it's really important that they understand where all the stuff they apply comes from, so that they know why it breaks, when it breaks. So that balance is really important. You have to use something like an autograder, because marking code is incredibly time consuming. And I think it's very difficult to be consistent and fair and check everything if you're marking code manually. So, but we need to have tests. I have tried to just do practicals and that sort of thing, but I think you need to have a test where the student has to show that they've mastered something. I'm not at this point sure if I'm going for the open book or the closed book. I'm indifferent at the moment, but there must be a test. And there is this SASA practical exam requirement. So if any of your institutions are SASA accredited, then that's something that they're pushing more. And I think in future we're going to not be able to avoid that as much. And Gradescope is obviously just wonderful. That's my take home. Thank you, Farai.